Welcome to The Explainer. Today, we're diving straight into the massive engineering and precise choreography behind erecting a space frame canopy from the ground up. We're going to look at the exact methods, the heavy machinery, and the incredibly strict safety rules required to actually pull this off. So, to kick things off, we got to ask a pretty fundamental question. How exactly do you build an intricate, heavy steel roof that seems to just float above a solar plant car park? I mean, it looks like magic when it's finished, but the reality is an absolute masterclass in physics and planning. All right, here's our project blueprint for today. We'll be covering laying the foundation, assembling the space frame, the heavy lifting, and finally, those high-stakes safety protocols. Let's start with phase 1, laying the foundation. This is all about the groundwork and those essential pieces. Before we actually start building, let's get familiar with a couple of critical terms we'll be using. First up, we've got nodes. These are basically the central, spherical joints where all your pipes and bolts connect. And then we have purlins, which are the horizontal support beams that actually hold up the roof structure itself. Now, if you're having trouble picturing all these metal pipes, spherical nodes, and bolts, honestly, just think of this entire massive structure as a giant, high-stakes KNX or erector set. It's exactly like that. You're locking individual geometric pieces together to create this incredible rigid frame. Except, unlike the toys we played with as kids, getting this wrong has some pretty disastrous consequences. And setting up this giant KNX set, it literally requires millimeter precision. Crews don't just toss precast foundations into the dirt. They have to excavate to the exact required level, verify the correct axis and elevation, thoroughly clean the foundation bolt threads, and meticulously chip the concrete to place shims just to hit absolute foundational perfection. With the foundation perfectly set and double-checked, let's move right along to step 2, assembling the space frame, or as I like to call it, putting the puzzle together. The method here follows a really strict sequence. After mobilizing the site, crews crucially pre-assemble the fabricated structure right near the erection front. Vertical steel columns go up first, followed by the assembly of the space frame grids, and finally, the sheeting. Just think about how this geometry comes to life in practice. You've got these incredibly intricate node connections locking the struts perfectly together. But the real game changer is that whole massive segments of this frame are safely pre-assembled down on the dirt long before gravity really gets added into the equation. Which brings us to phase 3, and definitely the most nerve-wracking part of the whole operation. The heavy lifting, cranes, tension, and a whole lot of gravity. Now, you absolutely do not just hook up tons of steel and hoist it blindly. Riggers have to execute a mandatory pre-lift check. They elevate the massive canopy grid just 6 inches off the ground. Why? Because they need to find and adjust the exact center of gravity. If the load is off balance, you definitely want to find out at 6 inches, not 60 feet in the air, right? Getting the crane set up to execute that lift safely is an exact science. The machine essentially has to become an immovable counterweight. That means checking for soil stability. The ground has to be perfectly compacted. Outriggers are fully extended on flat ground onto spreader mat pads that must be larger than the outrigger bottom. Plus, all the crane's tires have to be completely elevated off the ground. Throw in a strict minimum 3-meter safe distance from any excavation edges and a minimum of 2 tag lines attached in opposite directions. Yeah, it's intense. The sheer scale of this is just wild. You have this massive crane carefully hoisting a fully pre-assembled canopy segment straight up from ground level. It really puts into perspective how absolutely critical that perfectly anchored crane setup actually is. As that huge space frame goes up into the air, it basically acts like a giant sail catching the wind. To combat this, those 2 minimum taglines we just talked about are absolute lifesavers. They allow the workers on the ground to safely guide the massive canopy to its exact drop-off point without letting it spin out of control. Everything we've covered so far requires intense coordination and, frankly, carries massive physical risk. Which brings us to our final section, part 4, high-stakes safety protocols. It's all about protecting the team. This specific rule right here is absolute 0 exceptions. Nobody shall pass, walk, or stay, or cause anyone to be under the suspended load. Period. It's a massive hazard that can have immediate, fatal consequences, so the site is strictly barricaded to prevent anyone from wandering into danger. Securing those final connections happens at dizzying heights, and the margins for error are basically 0. If they're using scaffolding, it needs locked caster wheels, a clearly displayed scaff tag, and a maximum height of 3.5 to 4 times the base width, all built by a competent person. If they're using man lifts, you need a trained operator. It has to be on a compacted surface, absolutely no overloading, and no lone working is ever allowed. Someone is always watching your back. At the end of the day, a safe site is an organized site. Teams implement a strict 5S housekeeping system because clutter causes accidents. It's all in the preventative details, like checking that pressure hoses have whiplashes installed in case they snap, ensuring diesel generators are earthed and sitting in a drip tray, and rigorously inspecting all lifting gears for any damage, cracks, or deformation. You always have to verify those safe working load capabilities before anything moves. It really leaves you wondering. Next time you park your car under a floating canopy, will you look up and appreciate the invisible engineering ballet that put it there? Seeing the sheer amount of planning, physics, and strict safety regulations required just to build a single solar car park roof really changes your perspective, doesn't it? Thanks for joining me on this explainer today, and I'll catch you next time.